So this video is about lambda functions or single line functions in Python, and for anyone that hasn't seen a lambda function, well, you're going to see it now. But basically what it is a one-line function. But before I even begin on that, what I'm actually going to do is go to one of the AI chats and just see what it kind of like says. And I've actually already typed in here lambda or single line functions in Python. I don't know what it's going to give me back. Let's just zoom in a tiny bit and kind of like hit return. Hopefully we can see this. I'll make it a little bit clearer. So it says here are a few key things to know about lambda functions and single line functions in Python. Right, lambda functions, which are called anonymous functions, are small anonymous functions that can be defined in line without a def statement. They are defined using the lambda keyword followed by the function parameters, a colon and a function body. I'll go through this and show what it actually means, but I kind of like describes it a bit further here. But instead of basically creating a function in our normal way in Python, when we do the definition of a function and then the function name and then its variables, what we do here is we write lambda, and that is kind of like the indication that we've got an anonymous function. I don't know why the word lambda is used. Like, well, you know what? In JavaScript, it's much nicer because in JavaScript you have something like this, which is you have I think they're called arrow functions, and they look like that, and they kind of like look more like functions, and you sort of like know your code block, and you don't have something here called lambda like that. That's kind of like, I don't know, it kind of doesn't make sense nearly. In fact, so much so that I might even ask the actual question itself. But let's just go through a little bit more and see like what's our single line function. And this is really the comparison, by the way. So single line function can be defined using a regular def statement. Well, we're used to that. That's exactly what we do in Python. So like, you know, why not just do this? But written on one line by separating the function body statements with semicolons, for example, like this. And the whole point of these lambda functions is that you're writing something small and cute. Well, guess what? You can write something small and cute straight away with a regular function. And, you know, this lambda thing is actually quite long in a way. So, I don't know. And does it add any value in particular? But anyway, unlike lambda functions, single line functions defined with a def can contain multiple statements. Well, that's better. Also, they can contain type hints, which I'm going to show as well. Lambda functions do not have a name or a docstring, so that's kind of like the difference. If you don't want a name and don't want a docstring, lambda functions are the way to go, I guess. Maybe that's one use case for it. While single line functions are defined with a def, are proper functions that have a name and contain a docstring. Although I guess the docstring here is just an empty string, so the docstring here will actually return none. So if we do a dot double underscore dot double underscore doc double underscore, I expect we're going to get a none back on that. In fact, I'm quite sure that we do get none back on that. Lambda functions are useful for short, simple inline functions that don't need a name. Okay, if you don't need a name, but then we can use a double underscore or something in front of it to show that it's sort of like, I don't know, like something that we don't use or can write over or something. Single line functions are useful for short functions you may want to name and document. Okay, so let's just go and see this. But the other thing that we were asking just before we go to the code is, why is it called lambda? Right? I'm sure there's a great reason for it. Well, there we go. The lambda keyword in Python comes from the lambda calculus, a module of computation, and so forth. Lambda calculus, anonymous functions are used by lambda. So that's kind of like where this actual keyword came from. Here, lambda x indicates anonymous function with the parameter x, and x plus 1 is the function body. Okay, so anyway, let's just actually go into the, let's just redefine a bit. So in essence, by choosing lambda as the keyword to define anonymous functions in Python, Van Rossum, and he's the creator of Python, was able to provide a compact syntax inspired by the mathematical lambda calculus formalism expressing the concept of anonymous functions. So that's where it came from. This result is a very clean, readable way to define small anonymous functions in Python. I would argue that this is probably a little bit cleaner, and maybe the Pythonic version of it might have looked something like that, but you could argue that, I don't know, maybe that's not the way. But anyway, let's just go into this. So we will say that, well, in fact, maybe we'll just even take the example from the top here because it's easier to do. Let's just do a copy of the code, and we'll do that over here. And what's this actually saying? This is saying we've got a function. It's an anonymous function. It doesn't have a name. It's going to be assigned to the value of x. But it's got two arguments here. The arguments are a and b. And what it's going to do is add a plus b. So, and then we can do something like, I guess, x. And then it's going to say that we've got a as any. And this is a bit, well, I'm going to say it's a bugbear because I can't type in what it's going to be. Maybe I want it to be an integer or a float or a boolean or something that I can concatenate, but it's an any and an any over there. So let's just say it's 10 and 5. We can then run that piece of code and we get 15 back. But since it was any and any, it could be 10 and hello. And if we do that, we get a type error. So, you know, maybe it's short enough that that's never an issue. So let's just go back and we'll do 10 and 5. Now the alternative example, so this was our lambda example over here, so that is a lambda example. We're going to create a new piece of code over here and we will do a single line def example, and that one's a little bit easier because we can do def over here and we'll define our function, and this time we're going to call it, I'm going to do this like double underscore add like that, and we see that it actually gets grayed out, which is quite neat. You could put a single underscore or a double underscore. Now the doc string over here we're going to remove because we want to make it a single line function, and we're going to put the same two variables in, which is an a and a b. But this is the advantage, is if we've done it as a function, you can actually type in. So we can say I want to have an integer here and I want to have an integer here. Like that. So we can type in what we want, and we can also say that it actually returns back an integer, although Python's going to recognize this anyway. And what we want to return back is exactly the same as above, which is this a plus b, like that. So now when we look at this add function, we actually see that it's got a full signature. It's a function. The function's name is add, and it takes in two variables, a and b, and they're both integers, and it returns back an integer. So that's kind of like nice and cute. We never got this for our lambda function. We had an any, an any, and an any. But maybe because it was anonymous, that was acceptable. We can now call our add function over here, so we can say underscore add. Oops, let's just do an, I'll do an add because actually it will come up in IntelliSense anyway, which is quite nice. I love IntelliSense. VS Code is great, IntelliSense. And we've got the type hinting straight away already, so we can do the same 10. And the thing is now we are kind of like, if we're following at least the on-screen prompt, we're told that b is an integer. We could put in a float, it'll work, but we know that this won't necessarily work. We're expecting this one to throw an error back. Now when we run this, well, we get the type error, but even if we were to actually put in the 5 over here and run it, yeah, we still do. We get back a 15 over there. So both cases work, and you kind of like see the difference, should we say, which is here we can type hint and here we type hint, and here we don't. Let's make these look even closer together. We can actually define this function as x, and then over here we will call it x, and these two things now look completely identical, and we can run our function and they look nearly exactly identical. Now if we were to remove the type hints over there, we now see that these functions are nearly identical even in terms of actual size, in terms of the length of the string. And literally what we have here is lambda, which cost us 1, 2, 3, 4, 5, 6 characters, and over here we got a return which actually kind of like had the same cost. So I don't know, they're very similar. I think that, and I actually did check this out somewhere else previously, but it was something like, are there any cases where we have to, and you might have your own comments on this, and there are very exceptional cases, I think, where we need to use lambdas in line inside a function, so where we have to use a lambda function because we cannot use a regular def. Let's just see what comes back here. I didn't ask the question when I actually did previously, but there are a few specific cases where lambda functions allow functionality that cannot be achieved with regular def function in Python, and here's some examples. But actually, I think that this top case actually can be replaced because you can define your single line function above, but it would cost you one extra line of code in these cases. Inside list comprehensions, that's an interesting one. So I can actually write here, provide an example of inside list comprehension, and we might get a tiny piece of code, and I wonder if we can counter that. So here's our list, and here is our list. Oh, I see what it's doing here. So my question, and I might leave it for another section because I don't want the video to get too long here, but the question really is if we paste this piece of code in here, which is a working piece of code, and I don't like this piece here because when you type this S for the S dot upper, so S dot, it doesn't know that it's a string. So it doesn't type hint, so we have to do the upper on our own, and we like the type hinting. Now, if I was to make this same function again, so something like this, uppercase strings, I might want def upper, right, or def u, or def underscore, which is quite commonly known, but I'll do a def u, for example, over here, and it takes in a string and then it returns the string dot upper. Now notice again, it's not type hinted at the moment, but if I was to do this, which was to say that we're expecting to get a string in here, all of a sudden the upper popped up and it's recognized. So we get all of the IntelliSense picks out straight away all of these string methods. So we've got an s.upper over here, and in this lambda function now, I think we can replace that. So what I'm going to do first of all is just run this piece of code without, and we've got our, let's have a look, have I run it all correct? That was straight out of here. Oh yeah, we do. We get the output that looks like that. Lambda s.upper. Okay, let's have a look. Let's see if we've got that one. Lambda. So that actually didn't on its own look that useful anyway, to be fair. So I'm going to actually run this case here. So let's do a hash and move this one out and have this one. And instead of doing the lambda function now, I'm just going to do an u of s for s in strings. Now I believe that's actually going to return back the uppers, so let's just run this piece and we get the foobar baz. That's moved to uppercase. Now you wouldn't actually do this because you just do, you didn't actually ever need this function, so I'm going to say that this was actually a bad example by the GPT processor here. You know, it's come up with something that example wasn't a good use case. I certainly wouldn't do that. So if you're watching this video and you do find a good use case, or like I've misread it in some way, then by all means post a comment on that. But actually what you would do anyway, you not only would you not have a regular function here, you could actually comment this one out altogether, and you could achieve the same thing by just doing s dot upper in the first place for s in strings like that. And notice as well that, in fact, when I did it, I wonder if it does do s dot, yeah, it does. It automatically recognises it in the IntelliSense, and I presume it's recognising it because it knows that S is a string straight away. So yeah, that's basically it. That's lambda functions or single line, lambda functions or single line functions. I still have a preference to nearly always go with a single line definition example like this, but post your views either way. It'd be interesting to see what the consensus is on lambdas or single line functions. And if you found this video useful, hit the thumbs up button, hit the follow, hit the like. If you didn't find this video useful, also still hit the thumbs up button, hit the follow and hit the like. And thanks for watching lambda functions or single line functions.